All right, good afternoon. My name is Sandy Spoon. Thank you for that introduction. Sorry I didn't catch all of it. So I am a current person from Pasco Scientific. We're based out of California in the USA. I'm going to give you a brief background about myself, and then we'll move into some of the experiments that I'm here to show you today. So my history is I have a physics degree from USC. I went on after my physics degree and fell in love teaching, so I got a master's in education. I went on to go teach high school. I taught high school in a couple different states, including Chicago. Chicago was an interesting experience. It's the only school I've ever taught at where physics was mandated for every student to graduate. So I got to work with the largest physics department in the U.S. in a public high school. So I went from there to start working with Pasco. And part of the fun that I've had working with Pasco is exactly this type of event. I've got to travel around the world. I work in all the different regions of the globe. And I get to work with teachers just like yourselves. So that's just one of the many pleasures I have of now working at Pasco. And I hope to show you some of the fun stuff that we're working on. So what I'm going to be showing you today is the newest thing that we have for high school and university physics coming out of Pasco Scientific. And that is going to be my 850 universal interface. How many of you are familiar with Pasco products? Is there anyone who's used anything Pasco before? Okay, perfect. Oh, one person? 2, 3, 4? Oh. Okay, so we have a decent amount of Pasco users. All right, and then the software I'm going to be using today is called Pasco Capstone. So we'll go ahead and get that started and show you what that looks like. So Pasco Capstone looks completely different than any other software that you've seen before at Pasco. And it has a couple of really neat new features. So I tried to pick several different activities today that highlight those key features. All right? The first one that we're going to start off with is a very basic, very common lab that's done in pretty much every physics program I've ever been in. And that is measuring the motion of a cart on a track. Okay? So for those of you familiar with Pasco's products, you know that we are quite proud of our low friction carts, our aluminum tracks. And on the end of my track here, I have a motion sensor that's going to be measuring the motion of this cart from down the track. So we're going to start off just with a very quick, easy experiment. Just make a graph. On my y-axis of my graph, I'm going to look at position. And I'm going to start recording. I'm just going to pull my cart out and go up the track. All right. And stop recording. And I'll zoom in on my data here. Okay, that's not what I saw. Let's try that one more time. Can I get another mic? Can I get that? I can, yeah, it's not a big group, right? I think everybody can hear me, but do I need this one? Okay. Everybody, so, okay. Turn it on. Go. Oh, that's kind of got a bit of an echo. Okay. Is that better? So, okay. All right. There's a bit of an echo on that, isn't there? How about I think you guys can hear me, right? I'll use my teacher voice. We have an informal discussion here. All right, so I'm going to go ahead and start with my motion sensor on my track. All right, so as you can see, there's my motion sensor data. If I just kind of move it with my hand, you can see it coming up and down. Push it up. All right. So many of you have probably seen this type of experiment before, where you have just a basic position graph of your cart going up and down. Anybody want to kind of explain the different parts of the graph? Right, that's always the first question we ask, and we ask students to come up and point, okay, what does it mean as the dots are going up? That means the cart's going up the track, right? What does it mean as the dots are coming back down the slope? That means the cart's coming back down the track, right? Right. So the activity I'm doing with you today is a couple of lessons into my physics course. This isn't my first thing I would start off with. I start off just getting them to understand position, velocity, the slope of position, acceleration, the slope of that, right? So I'm kind of building the foundation up to this activity. So at the point where I'm doing this activity, the students are pretty familiar with the position, right, of the cart going up and down the track. So what I'm going to be doing with this one is kind of moving it to the next level, which is energy, right? So we're now going to start connecting the position and the velocity of the cart to potential and kinetic energy, right? And one of the trick questions, one of the key questions for students is what does the potential energy do as the cart goes up and down the track, and what does kinetic energy do as the cart goes up and down the track, right? So the goal of this, and the title of this workshop is trying to see the unseen. So how can we take this very abstract concept of potential kinetic energy and actually put it into something they see, right? And when Pasco's traditional software, you could show them a graph of this, and the teacher would point, this is what's going on. But it still had that abstract layer that didn't quite connect with the students. So in this one, we're going to build that same calculation. We're going to calculate potential energy, kinetic energy. And then we're going to use a webcam to actually look at the different spots of that cart as it moves up and down the track. So we can very quickly play back our data as it's synced with the video image of the cart going up and down the track. Okay?
OK， 他是说这个东西可以做位置、速度、加速度等等的实验，而且它牵涉到很抽象的能量关系跟我们物理讲过了。他现在最新来加一个 camera 在那边，他在教学的时候，不仅有现象的 camera 给你秀出来，还把所有的图形、能量什么东西都给你秀出来，让教授上课的一项全部都给你找出来。就这样，我们4年才看到作品，你看，做的
OK。So just to give you a preview, I'm going to go ahead and show you one new feature of Pasco Capstone, and that's just playing back your data even without video footage. So I'm going to go and access my playback tools, and you can see I can play back any data that's collected. So I'm kind of time shifting the event to the conversation about what happened, right? That's a huge conceptual thing for students. Maybe they missed it the first time when it happened. Now they can take that data and go back and watch it again. And they might even want to change its speed, so we can even play it back at half speed. If something happened too fast, we can slow it down and watch it back in slow motion.
他这边就可以把速度整个调整，把刚才的资料全部秀给你看，再来聊一下。他速度算很慢，给你看，大概是你看还有什么地方你再帮你多解释一下这种物理现象。
Okay. Alright, so I'm going to go ahead and make a new page here. And on this one, I'm going to create a movie display. So I'm going to bring in my video image. Alright, and so this is going to be recording the movie with sync data. As you can see, I have my little webcam down here on the end. And it'll show me a little preview. So there it is. So this is my little webcam down the end of the track. Alright. And I'm going to add a graph beside that. So we're going to bring the graph in here. Okay, and on this graph, we're going to look at our position. All right, so let's delete our last run and let's kind of start over there. We know our run so far. All right, so this time, whenever I start recording the position, it's going to record that video at the same time, simultaneously. Okay.
同时把时间还有它的图形整个作品让它变成作品看啊。
Okay. So there you can see the data on my right. We'll go ahead and scale it so it's nice and big there. And I know the camera came out of focus as it got too close. So let's go and see what that looks back as we play it back. All right. So now the first question, right? What was that question again? When is the cart closest to the sensor, right? When does the cart go in at the top of the track? So we're trying to take not just the sensor measurement, but connect it to something that the students actually saw. So now I can kind of scroll back in my video and say, okay, let's go back. And right there is when it's the closest. And of course, that's when the data's at the peak, right? So I now have a very clear connection for the students knowing what happened here to what happened here in this graph, right? We're trying to build up that connection of what's going on in the measurement, what's going on in the graph, what's going on that they actually see. We're trying to intertwine those three things together.
所以呢，你看他可以问学生哦，你看他就给你倒回来，都位置跑到上面去了，你看他图也在那上面，到底这边有什么关系？就是说图和你的影像同时都给你出现，你看你能不能够考虑到这样的一个真实的情况。
Okay. So now let's take it to the next step. Let's introduce that energy component to it.
May I ask some questions?
Sure. Yeah.
It's very interesting demonstration. However, have you calibrated the length of your track?
No. I haven't done anything. I just plugged it in and started going. I haven't done anything. No.
So I mean, before you do experiments, you need to
Calibrate in this one, I'm not calibrating anything. In this one, I just plugged it in and started recording data.
So you think that's not important? Or,
And this one, not so much. This one, it's not as important. Some other experiments that I can show you later, some of the other sensors we have, it's much more important to calibrate.
It's in calibrate software or something.
But
It's supposed to be, right?
let me clarify, because I think I know where you're going. You think that this camera is calculating that distance. No, that's not what's good. So this sensor is calculating that distance. The camera is just helping the students connect what they're seeing to the data that this sensor is measuring.
So the ultrasound sensor doesn't need
No, it doesn't need calibration. It is calibrated at our factory. And very, very rarely should it ever need recalibrating. If it does, feel free to send it back to our
What I
company.
would suggest is if there is a chance to do this calibration, will that be better?
In my case, no, because my conversation is position, velocity, acceleration, right? And I'm trying to get at students understanding this data and understanding this graph and what that means in terms of physics concepts. A calibration in this case isn't going to help my students understand those things any deeper. Now, other activities I could do, yes, calibration is very important. Like if I'm doing an activity that involves pH is a great example, right? pH is very important to be calibrated to observe that. Or a colorimeter, right? If I need to calibrate it based on the light refracted through a substance, then that one's very important. But in this one, I get great data right out of the box. So now a conversation that I will have is error, right?
Yes.
So there's some error involved in this. There's error in every measurement that you make. And that's an important concept for my students to understand. So very early in their science experiments, we start looking at sources of error. And the main source of error in this experiment is the sensor, right?
刚才讲的，我刚才就可能从来带到太清楚，就是这里是个 sensor， 就感应器，那边是一个是像一个，刚认为教授讲得很好，说用把它调过来放在这边一块来做，他说，其实他的建议不需要这样做，但他的建议是说我们在做这个实验之前啊，先做给学生看，先向这边我来讨论，这样下来，然后看看都有什么问题，然后学生来看看也可以来做。
Yes. Okay. Exactly. That's my exactly. I'm trying to get as much of the technology to kind of disappear in the background so that the students can learn what is position. And my ultimate goal in this activity is to tie that to potential kinetic energy. And that's what I'm getting ready to do now. Okay. All right. So one of the other neat things that Capstone kind of allows the students to do very quickly is create calculations, right? Now I'm assuming that most of you probably are going to introduce these equations to students at some point. You might have them discover these calculations via derivations. That's a common practice in physics. So most of the time, by the students are coming back to this lab, they probably have seen the equation for potential kinetic energy, and I'm sure everyone here knows what that is. And I'm going to use PE to represent my potential energy. I'm going to say that's mass times gravity times height. All right? And we're going to measure that in joules. And notice Capstone instantly says, okay, well, you need to help me figure out what mass and gravity and height are. So we're going to help it figure out what those things are. So mass is the mass in my part, which I would need to go weigh, but I'll go ahead and tell you this. These are pretty close to 0.25 kilograms or 250 grams. Notice Capstone's also trying to provide the units that it knows are scientific units over here, so I always have a list of units. Now gravity is an interesting one because gravity is a universal constant, right? So students might want to type that in, or they might want to rely on Capstone's built-in library of constants. So I can go through my built-in suggestion here, and I can see that the gravitational constant is acceleration due to gravity. So it's kind of already built in there, right? Of course, it has meters per second squared as units of gravity. And finally, height. Now, this is where things get interesting, because this is where we're starting to incorporate the data from our measurements, right? So I'm going to pull in my position, because that's going to help me calculate the height. But we know that's not what the height equals, right? Height is a function of position. So I'm going to multiply it times sine of my angle, right? And in this case, I'm going to go ahead and assume typically I would have a, thank you very much, lab assistants. All right, so can you tell me what my angle is? About 5 degrees. Okay. And I need to make sure that I select degrees. All right, and height is going to be measured in meters. All right, so I now have all the components I need of potential energy. Make sure everything is set up. Now I can come over here to my position. I can switch that over to potential energy. So I have a calculator. Now let's go back and see what does potential energy do. And we can quickly see that students now have the ability to go and see what is the potential energy doing at different parts of the cart going up and down the track. Right? So the parts at the bottom of the track, potential energy is at its lowest. And what happens as the cart moves up the track? Increases. Where is potential energy the greatest? When it's at the farthest point up the track, right? And they're not having to remember all this. They're not having to remember. They have the camera, right, to help them remember what happened. So they're connecting these concepts back to something they've already observed, and they're shifting their observations to the moment where the learning's happening. So we're time shifting the hands-on experiment to where the learning's happening. Okay? All right.
这不需要翻译吧？啊，这很简单，那就找到 potential energy 这个位能了啊，要不然转换过来，让你直接按照刚才的位置时间关系图，就把你转换成那个位能时间关系图，把它做出来。没错。Andy, if you take two graphs,
okay.
我现在去请他说，我还是要看刚才的位置时间关系图，上面的图说给我看，看可以做到。
Okay, what would you like on that other graph?
Yeah. Position, 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 position time, position time, yes.
Okay, is that good?
Yeah.
Okay. So at this point, I'm probably going to go back and kind of connect this to my next form of energy, and that's kinetic energy. So I'm going to go back into my calculator here, and we're going to create another one for kinetic energy, which we'll call KE. This one's going to be 1/2 times mass times velocity, and for those of you who are familiar with our motion sensor, you know that it also calculates position and acceleration. So we can multiply that, and we're going to use our calculator buttons to go and square it. There's our kinetic energy. And it already knows what the mass is because it's been defined earlier in the calculations. All right?
把位置时间关系图还可以把它微分一下，把它做成速度时间关系图，然后把它算过来，让共鸣算出来，很有趣啊。
So maybe let's switch this position one over to kinetic. And once again, we go back to our playback mode, and we can see where is kinetic energy the highest. Kinetic energy is the highest when the cart's at the bottom of the track, right? And kinetic energy decreases as it moves up the track. And we can quickly now see kinetic energy is the lowest when potential energy is the highest. And we're starting to see there's this inverse relationship between the two. As my potential energy increases, my kinetic energy is decreasing, right? And we're trying to make those concepts very tangible, very, very visual things that the students see, right? So just kind of rewind here and play back through that whole run, just to show you what that looks like. And always remember, if that's too fast, we can always slow it down. it already knows what both of those things are, so it's not going to ask me what they are. And maybe we'll go and add one more graph. This one we're going to call. There we go. Let's watch it one more time with all three. So we see total energy reaching a climax, and then it kind of stays constant throughout the rest of the activity. And let's say that, it's kind of hard to see that, especially on this screen where we're kind of confined by the projector. Let's go ahead and open up another page just for those of you who want to get a closer look at that total energy. You can always just go open up another page. So there's what that total energy looks like. And thanks to my assistant's angle measurement, you can see that it's pretty constant, right?
我跟大家介绍是total energy， 我们是称为机械能。好，我们大学里面高工研究大机械能，这个专业叫什么？机械能应该是这块嘛？你应该做出来，差不多相当于一条直线。
Alright, so there it is. It takes off. It reaches that total amount of energy, and it keeps it until it comes back down again. And I stopped it at the bottom. Okay. So that is my first one. I want to make sure I'm keeping an eye on my time here. Try to move through 4 experiments in the time I have. Are there any questions about that? That is just a quick, efficient way to introduce students to potential kinetic energy, and doing it with actual real recorded video, real things that students are used to doing, right? Pulling out the camera, pulling out their phone, right? Taking pictures, recording what's going on. We've taken that ability and tied it into their data collection in the graphs, right? So, if there's any questions?
有个问题想问大家一下。
Alright, so I'm going to keep talking while I tell you about my next experiment. So my next experiment is a circuits experiment. Can we go ahead and take this? Thank you, Dan. Good catch. Comes with a warranty, so. Alright, so in our circuits experiment, we're going to be looking at an RLC circuit board. Alright, so we're going to be looking at a resistor, capacitor, and inductor in series. Right? And typically the hard part for students, so at this point, they've been introduced to Ohm's law, they've been introduced to Kirchhoff's law, they've been introduced to RC circuits, so they understand a little bit of the core concepts, and now comes the big challenge. Right? What does an inductor do to the circuit? How does that change things? And we know this is a very important bridge for students to go from basic circuitry to more higher level concepts of circuit dynamics. So we're going to kind of make a quick lab here that's going to look at how does RLC circuits behave. And we're going to use the 850 to do that. And we're going to use a couple of neat features about the 850. One is it has 3 signal generators. It has a high power 15 watt power amplifier, and it has 2 high-speed signal generators that each go up to 500 kilohertz. Okay? Now 500 kilohertz is only important if you have a box that can measure and keep up with it. This box measures at 10 megahertz. So we're going to be looking at the same components that you would typically be using in other types of circuits, so I don't need any fancy components here because I have a sampling rate that's able to keep up with the LRC circuit phases that your typical components will do.
他现在做实验是电路实验他做了一块很简单的电路板可以做RL 电路或是感应电路或者感应的信息的。不过他做过这个东西很棒，他说做过这个东西你不要再买那个什么信号产生器，他说这个信号你都有了，怎么做起来什么信号机具什么都给你做完了，说买这一套就可以把它做出来，有这一套设备要850，要850这个东西就肯定把它整个实验做出来，我们拭目以待看看，好吗？
So I'm going to kind of just talk as I put this together. This is going to be my power supply, so this is going to go across the whole circuit. All right. I'm going to be looking at 2 different voltages. All right. So I have 2 voltage sensors here. I have the capacity to measure up to 4 simultaneous voltages, and this one I'm only going to be looking at 2. All right. And before I attach those to the regular paper. Got it. I want to go ahead and complete my circuit, so let's go ahead and complete the rest of our circuit here. So I need to bridge together my inductor. By the way, this is a 6.8 millihenry inductor, for those of you who want to do the calculations in your head. All right. I'm going to bridge that together with my first capacitor. My capacitor is 3,900 picofarads. Right. And the last thing I want to do is bridge that to my resistor. And the resistor I'm going to be using in this case is a 3.3 kilo ohm resistor. So that's going to complete the whole circuit. So let's go ahead and attach our sensors to it. So my first sensor is going to go across the entire board. So this is going to go all the way from the inductor all the way over to the resistor. So let's go ahead and bridge that one. And notice I'm using banana cables that are kind of easy to attach to each other, so I don't have to worry about alligator clips or those kind of things. Grab my second voltage sensor. And my second one's going to go just around the resistor. So I'm going to be measuring the voltage across the entire board and the voltage just across the resistor. Okay. I might ask you to prove that. Does that look good to you? I might need your help. Okay. I make mistakes. Okay. So we're just going to open up the new experiments. All right. So we're going to begin by telling the software what we have connected. So I'm going to tell it that I have a voltage sensor connected to channel A and channel B. All right, and now we're going to go into the signal generator. Now, the signal generator has a lot of new tools that our previous version of our software and hardware did not have. Okay. For some of you, you might be familiar with the many waveforms that you can do with Data Studio and the 750. We have all those waveforms are supported on the 850.
那意思说，他这边会产生信号波，或者信号波是另